Hello, everyone, and welcome back. I hope you've had some time to practice everything we learned in the previous lesson, although it wasn't much, but still, I hope you did the task that I assigned you and even tried to make some more programs on your own by experimenting and even making mistakes. In the last lesson, we learned how to install Python, set up Visual Code, write our first Python program, and use the print function to display information on the screen. At that stage, every program we wrote had one thing in common. The output was never changed. For example, if I wrote print hello, the program would always display hello. Let's think for a moment that suppose you're creating an application for a school. Would every student have the same name? Or would every student have the same age? Of course not. Some students' name could be Sarah, David, Ahmed, etc. But if we hard code every student's name into a program, we'd have to rewrite the code every single time. So that would be really inefficient. Instead, we need a way for the computer to remember information. That's exactly what we're going to learn in our lesson today. We're going to learn one of the most important concepts of programming that are variables. So before we write any code, let's imagine something from our everyday life. Imagine you have a box. Right now, the box is empty. Now, imagine that you place something inside the box, say a book. Now the box contains an item. Later, you remove the book and replace it with something else. Let's say a flower. But the box still exists. Only its contents have been changed. A variable works in a similar way. A variable is like a container, a box. Instead of storing books, it stores information. That information could be a string, a person's name, someone's age, a number. It can be a decimal, that is, a float, which we are going to learn today, or even it can store a boolean value that is true or false. The important idea is that a variable stores information so we can use it later. Let's create our very first variable. Open Visual Studio Code and create a new file. Name it anything you want. I have just named it hello.py. Name is equal to quotation marks because this is a text we will be storing. It's a string, so we have to use quotation marks the same way we used quotation marks when we were supposed to be printing a text in the print statement yesterday's lesson. So simply type any name. I'll type Alice. So on the left side, we have a variable name. It's simply the label we give to our container. Then we have the symbol here. Now, to many, they know it's called the equals sign in mathematics, and it's true, but in programming, it's called the assignment operator. Its job is to take the value on the right side and store it in the variable on the left. You can read this line as store the value of Alice inside the variable called name. Now let's display the value stored inside our variable. So now let's display the value we have just stored by referencing it inside of the print function. So just below our first line, write print and no quotation marks and simply type in the variable name. I'm going to save this and hit run. And there we go. We have successfully displayed Alice. Notice something interesting. This time we are not using any quotation marks around the name. Why? Because the name itself is no longer just text. It refers to the variable we just created earlier. When Python sees print name, it looks inside the variable and finds the stored value, that is Alice. Now what if I wanted to print something else? One would say simply create another variable and assign it some other name, say John. But we can also change the value stored inside the variable we just created. by simply just replacing the name John. Now I simply type John and then, of course, save, because if you don't save, the output will be the same, that is Alice. So after saving, if I now run again, there we go, the output is John. Now let's take it a step further. Now type the following code. Now I will just replace all of it, First I will type in score is equal to 10. Then I will type print the score is equal to 10. Now let's take it a step further. Now write the following code. Score is equal to 10. Enter print score. Let's assign the value again. The score is equal to 25. Print score. Save it here and run this. Now you can see the output comes out to be 10 and then 25. Why? Because variables can change. When Python reaches the line score is equal to 10, it stores the value 10 inside the score and then prints it in the second line. Now when it reaches the third line, where we have written score is equal to 25, it updates the value stored inside the score from 10 to 25, and it is displayed again in the next print statement when we print out the score again. Now let's create more than one variables and try to print them out. We can create multiple variables, like name is equal to, let's say, Alice yet again. Then we can put age is equal to, now we don't have to use quotation marks in case of numbers, as you just saw, because they are numbers. We do not need any other thing. So go ahead and write another print statement, print name, and then print age. Let's go ahead and run this, and there we go. There is our output. Now let's imagine we want to create a program which greets the user by their name. Now it will be easier for me, as I can just hard code my name into the program. But what if different users run the program? It will still display my name instead of the user's name. Before we go on creating more variables, let's talk about choosing good names. Python has a few rules for naming variables. The first rule is that the variable name can contain letters, numbers, and underscores only. For example, student underscore name or mark 2025. These are all valid. Now, the second rule is that the variable cannot begin with the number. Instead of mark 2025, we cannot have 2025 mark. Also, no spaces are allowed. So that's the third rule. We can write student underscore name, but we cannot write student space name. Rule number 4 is that certain words have special meanings, as we just talked about, like print. Print is a keyword and should not be used to name a variable. Other variables include like if, for, while, and class. You don't need to memorize all of them, but if you accidentally do choose one, VS Code will warn you. Now we know how to create variables. Let's talk about what we are going to store inside of them, that are the different data types. So let's take an example first. Imagine you're organizing a kitchen. You wouldn't pour milk into the sugar jar or store the flour in a refrigerator. Different things belong in different containers. Computers work in a similar way. Python needs to know what kind of information it is storing inside of a container. In this course, we'll focus on 4 common data types that are like integer, float, string, and boolean. An integer, often shortened to int, and all of it is lowercase, is a whole number. For example, age is equal to 20 or age equals to 18 we just used. Notice that none of those numbers have a decimal point. Integers can also be negative. You can also use x is equals to -1. It is still a number that is integer, int. The second type of data type we have is a float. A float is a number that contains a decimal point. Floats are useful for measurements, money, scientific calculations, and in any situation where decimals are needed. The third is a string. A string is simply text. Strings must always be enclosed in quotation marks. For example, like we used earlier, name is equal to quotation marks Alice. Anything inside the quotation marks becomes a string, even if it is a number. For example, if we store age is equal to quotation marks 25 instead of age is equal to simply 25, that quotation marks has made the number into a string. And the fourth common data type is the boolean. A boolean can only have one of the two values, that is either true or false. Notice that both of them begin with a capital letter, that is T capital in true and F capital in false. Sometimes we are not sure what kind of data a variable is containing. Python provides a built-in function called type to tell us. Let's try it. So follow as I write the code. First, let me just remove all this. So let's write age is equal to 20 and print bracket type bracket age bracket as a parentheses. And now if I save this and I run it, and there we go. It's telling us the class is int, that is, it is an integer. Now let's try something different. Instead of age being 20, we can try, let's see, we can put in the amount of money I have in the bank. So we can say balance is equal to $2.5 or whatever. So I'm just going to write 2.5 and print type and the balance. Go ahead and save it and run it. There we go. It shows us that it is of the data type float. So far, every value in our program has been hard-coded by us, the programmer. But what if we don't know the user's name? Should we edit the program every single time that some new person uses it? Of course not. Instead, we will let the user define their name. This is called user input. Python provides another built-in function called input. Its job is to wait for an input from the user. Similarly as before, this input provided by the user also has to be stored somewhere. That is, in this example, we are using name is equal to input bracket quotation marks and inside the message. The message is not necessary. It is simply there to be more descriptive. Let's understand more from an example. So open up your VS Code and just follow me along. Name is equal to input bracket enter your name, semicolon, no, simply colon, and print name. Print name. So save it and focus on the output. Focus on the output. Now, as soon as I run this, the prompt to enter my name would appear. Now, whatever you type and then hit enter will be taken in as user input and stored inside the name variable. For example, I will just write my name. This is not my name, but ABC. Enter, and ABC comes out. Now, what if I wanted to write hello ABC, a greeting? We can do that by simply going into the print statement and using quotation marks hello, but we also want it to greet us by our name. So what we're going to do is first we will write the greeting in the quotation marks hello, and then put a comma between the string we have just written inside the print statement and the variable that we will reference. So the result would be hello space the name that the user have just input. So for just that, let me add in a space at the end. So there is a space in the output, hello space name. So if I was to save this and run it, there we go. So it's now asking me for input. So now if I'm going to give it some ABC, hit enter. Hello, ABC. Notice that a program is no longer fixed. Each user will get a personalized greeting. It's much more interesting than just printing a primitive hello that has been just hard-coded inside by us. Now let's collect more information. We can ask for user input again and again. Now follow along. Now what I'm going to do is I will delete all that. Name is equal to input, and inside of that enter your name, colon, enter city is equal to input, enter your city, and print hello space name, comma, quotation marks, you live in space, comma, city. Now if I'm to save this and run it, we will get the prompt for my name, ABC, and my city, XYZ. Hello ABC, you live in XYZ. So here's something you should know is no matter what the user types inside the input, it will always store it as in text, also known as a string. So now let's test it by using the type function we just learned about. So I will just go ahead and just get rid of all of that, and I'll just write age is equal to input, enter your age, space, and enter, oh, my bad, age is equal to input, quotation marks, enter your age. I will go ahead and print type. So now if I am to run this program, it will ask me for my age, which I will just input in, enter, and it is showing me that instead of it being an integer, it is a string. Now, this leads us to another question, that is, if Python stores the user data as a string, how can we perform calculations on it? As it is text, we cannot add 2 plus 3 if 2 is stored as a text. That's exactly where data conversion comes in. Let's take a look at a simple Python example. Type the following code. Age is equal to input, enter your age. It is repetitive, I know, but you have to, and there you go, I made another mistake. Input, quotation marks, enter your age, and then simply go ahead and print. Now, as we discussed in the first lesson, is that we can perform calculations. So when the user enters 20, Python actually stores quotation mark 20. So even though we typed a number, Python stored it as text. So now look at the second part of our program, that is print age plus 5. Python is trying to combine 20 with 5, which is one is text and the other is number, so it is not possible to perform a calculation. So we get an error, a type error. It is the same as thinking to add 2 kgs of flour with 2 gallons of water. It just cannot happen because the units are different, even though you can mix them, but the units are different and we cannot actually get to an answer. So what we do need to do is we need to convert the 20, the age we just entered, into a number and then add 5 so that the calculation actually happens. This process is called typecasting. It simply means changing one data type to another. For example, we can convert text into a number into a text, a decimal into a number, and also a number into text, but the number will just be displayed as, for example, 20.00, because it was a whole number. Python provides several inbuilt functions for this. The most common are int, bracket, float, string, str, bool, Let's learn each one. The int function converts a value into an integer. So let's take a look at our previous program and include this so that we can finally do that calculation. Now, after I'm done encapsulating it inside int, whatever I input will be first converted into an integer and only then stored inside a variable, thus allowing us to do the calculation. So I'm going to save this program and run it. Now, if I input 20, the answer should be 25. So there we go. The output is 25. A similar thing can be done in case of float, boolean, and all the other data types using the different data conversion methods we just looked at. So now let's practice together by writing a program which takes in your name and your birth year to calculate how old you will be. So open up VS Code and write the following program. Name is equal to input quotation marks, enter your age. We want this to be a string, so I will not be converting this input into any other data type. So after this, we will add in the year is equal to int input quotation marks, enter your birth year. And now what I'm going to do is, as we just discussed in the earlier lessons, is we can store a number. So I'll be like present underscore year is equal to 2026 and you are you. So go ahead and print out your name is comma name quotation marks and you are comma and we will add present year minus the year. So we will add present year minus the year. That will give us the age. So comma years old. So if I just go ahead and save this and run this and save the program, run it, and it's asking me for my name. Simply give him my name ABC and give him the year I was born in 6. And your name is ABC and you're 20 years old. So before we move on, I want to share some important habits. Whenever you are asking the user for an input and when you're designing the program, even before coding, you have to ask yourself, what kind of data am I expecting? Now that we know how to collect information from users, store it, and convert it into correct data types, I have a small assignment for you. As you can see, there is a Fahrenheit and Celsius converter. So use the formula. There is of course, a sample code down there, but it is easy enough. You should be able to do it yourself. We know how to take in user input. Simply implement this formula and make a program which takes in the user input, that is Celsius, and then the output is the conversion from Celsius to Fahrenheit.